Hello friends, myself Nimisha. Welcome to ACE Academy. Question is, consider the number 4 raised to n where n is natural number. Check whether there is any value of n for which 4 raised to power n ends with the digit 0. So in this question, we have to check the number 4 raised to n where n is natural number, and we have to check that is there any value of n for which 4 raised to the power n ends with the digit 0. So we have to check this whether 4 raised to power n ends with the digit 0 or not. We know that if any number ends with the digit 0, then it is divisible by 2 and 5. That is, it has both 2 and 5 as its prime factors. So any number, if it ends with the digit 0, then it has 2 and 5 as their common factors. So they are divisible by 2 and 5 also. For example, we can take example of 10, 100, 1000, etc. When we take the example of 10 and we do prime factorization of 10, then we find 10 as a product of its prime factors, that is 2 multiplied by 5. Now next number we can take as 100. When we do prime factorization of 100, then also we get 100 as a product of its prime factors, that is 100 is equal to 2 multiplied by 2 multiplied by 5 multiplied by 5. We put this as equation 1 and this is as equation 2. We can also see the prime factorization of 1000. In case of 10, this number 10, it ends with the digit 0 and it has both 2 and 5 as its prime factors. Here also the 100 ends with the digit 0 and it also has 2 and 5 as its prime factors. When we do prime factorization of 1000, we get 1000 as product of its prime factors, that is 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 5 multiplied by 5. We put this as equation 3. So 1000, here 2 we are getting 3 times and 5 also 3 times. Means the number this ends with the digit 0 is divisible by 2 and 5. That is, it has 2 and 5 as its prime factors. So now from 1, 2 and 3, it is clear that they have both 2 and 5 as their prime factors. So from 1, that is 100, we saw that their prime factorization, by doing the prime factorization of 100, we see that it has 2 and 5 as their prime factors, and also we see in case of 10 it also has 2 and 5 as its prime factors, and in case of 1000 also it has 2 and 5 as its prime factors. So in both these three cases they have 2 and 5 as their prime factors. Whereas in case of 4 raised to the power n, 4 raised to the power n, 4 can be written as 2 multiplied by 2. This n will be here as it is. So n is any natural number. Now if you put here n equal to 1, so we get as 4 raised to power n. This 2 is multiplied by 2. This n we put is as 1. So we get 4 is equal to 2 multiplied by 2. Now when we do the square of 4, that is when we put the value of n is equal to 2. So we write here, in place of n we write here 2. 4 raised to 2 is equal to 2 multiplied by 2. In place of n we write here 2. So 4 raised to 2 we get as 2 multiplied by 2 raised to the power 2. Therefore 4 4s are 16 here. And 2 we are getting 4 times when n is equal to 2. When n is equal to 3, we get 4 raised to the power 3 and we get 2 multiplied by 2 raised to the power 3. So 4 raised to the power 3, we get 64. 64 is equal to 2 multiplied by 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 2 here. We get 2 as 6 times here. In case of 4 raised to the power n, when we put n is equal to 1, we get 2 as prime factors. When we put n is equal to 2, again we get 2. When we put n is equal to 3, again we get 2 as a prime factors. So 4 raised to power 1 means 4, 4 raised to power 2 means 16, 4 raised to power 3 means 64. All this number does not end with the digit 0. We can see here in case of 4, 16 and 64. So from 4, 5 and 6, this 4, 5 and 6, it is clear that they do not have 5 as their prime factors. They only have 2, but they do not have 5 as their prime factors. Therefore, they do not end with the digit 0. Hence, they do not end. Here we can see 4 does not end with the digit 0, 16 also and 64 also. Therefore, they do not end with the digit 0. Hence, we can write here as Therefore, 4 raised to power n cannot end with the digit 0 for any natural number n. Hence proved. Therefore, 4 raised to power n cannot end with the digit 0 for any natural number n. Hence proved. If you like this video, please share it with your friends. Please like and subscribe my channel and press bell icon to get more updates. Thanks for watching it.